In this challenge question, we'll explore using dictionaries in memory diagrams. Dictionaries are heap values, and they're mutable, as we just discussed. So they work a lot like lists, and we'll visualize them like lists in that we will have a column for the keys and a column for the values. But remember, our keys are unique, and the way that we assign them is through subscription notation, as we just discussed in the previous video on dictionaries. For this particular code listing, we're using the Pythonic convention of saying, of assuming that the name variable here will be equal to main. So this is true, and this function call will occur because we're assuming this code listing is run as a program. So go ahead and pause the video here and see if you can reason through and work through what this diagram will result in and what the printed output will be. And we'll come back in just a few seconds to work through it together. All right, I've gone ahead and fast forwarded to line 4. So let's talk about what happened on getting global set up. Nothing new there. We called main. We've got our frame set up for main. Main had no arguments, but we established a local variable in main named game0, a dictionary of type string to int. And this is our focus for what we're working on today. So the game0 is established in the heap here, and we see that it's initialized to a dictionary literal. That dictionary is type str_int. So when we establish a new dictionary on the heap, we give it a header with the type, so dictionary string to int. And then the left-hand column will be for the keys. So our keys were KJ and ME, and our values correspond to those keys, 0 and 1. Remember, a dictionary is a mapping from key to value, just like a list is a mapping from index to some value. So we can do the same thing with the second game here. So this is game 1. And it's going to be assigned a new a new dictionary on the heap. So ID3 dictionary string to int, and the string keys are ME and EW, and 2 and 1 are the associated values. Great. So this has ID3 bound to game 1. And then we set up a call to merged. So we're going to have a variable named merged that we will be assigning to. So I might go ahead and make some space here to store that result, but we need to complete this function call first, right? So we don't know what merged will ultimately be assigned, but we can say merged is allocated some space in this frame, and then let's go set up the function call frame for this merge function call. So one of the things we can test is we can verify that this is actually a correct function call. We ask, is merge something we know about? And actually I miswrote this name in globals, so let me delete that D. The name of this function is merge, and we see, okay, there's no merge defined here. There is a merged variable here, but we're calling the merge function. And if we don't find something in the frame that we're currently working in, we go and we look in globals and we see, yes, merge is here. Of course, it's this function here. And then we look at, okay, what is game0? Game0 is dictionary str to int. That corresponds to A, the parameter, dictionary str to int. Game1 is dictionary str to int. It's also corresponding to the parameter B. So our arguments will correctly pass to A and B. So let's go ahead and set up our frame. So our frame here is going to be for calling the merge function. The return address is line 5. And we have A being bound to ID2, which was the ID of game0 in main, and B being bound to ID3, right? And so, right, so game 0, if I were to highlight it, game0, we look up what is game0. Game0 is ID2, and so we're assigning ID2 to A. That's why we established this parameter in this way. All right, so now we get into the merge function, and we establish a variable named result. And it is being assigned the empty dictionary. So ID 4. Whenever we see a new dictionary literal, we add a new dictionary to our heap. So dictionary stir int. And ID 4 is the result, right? So again, this is the line that we're working on here is this one. And this is the empty dictionary literal. That's what established this empty dictionary. Nothing is in it yet. And now we're going to work through this for in loop. For in loops are an interesting thing to try and diagram. So right away, this may have been something, if you tried it yourself, you're wondering, how do I keep track of this in a diagram? And here, because some of what's happening is a little bit more implicit than we're used to, we need to take care to just keep track of our state in our diagram. So when we encounter a for in loop and we're working with, say, a dictionary, one of the things, the first thing we'll do is we'll set up a variable. So the variable is going to be named key, right? And we don't yet know what key is being assigned, but we know that when we write a for in over a dictionary, that what we're iterating through are going to be these key values, right? So kj and me are what we assume to be assigned first in this loop, kj, second in this loop to me. So the other thing I like to do is just keep a little placeholder. And you can do this mentally, but I'm going to do it visually here and say that, okay, we're currently going to be on the string kj for this very first iteration of this for in loop. And so I'm going to go ahead and write in my key, and I'll stay in red here for emphasizing this for in loop is kj. And then we go into the loop body, right? So now we're going to process line 13, and line 13 is saying, okay, take what is a key. So a is ID2, right? So a is ID2, we look at ID2, and now we're looking up what's the value associated with the key, and our key is kj, and that's going to be 0. So what we're saying here is take 0 and assign it to result key. Now this assignment statement is, what is result key? Well, result is ID4, that's this empty dictionary, and notice there are no keys in this or values. So what we're trying to say is add the key named kj to this table and assign to it the value that we just calculated, which we just looked up. We didn't have to calculate it, which was 0. So we can add the string kj as our first key and 0. So if we were to think at a slightly higher level, what we're saying here is on this line, copy the value associated with some key in A with the same key in our result dictionary, and do this for every key in A. So in other words, copy every key value pair from dictionary A, which is this dictionary, into dictionary result. Okay, so we're done with our first step here. So we've just completed kj, and now we need to move on to the next key. So that's me. So this is us in our for loop, going back up to the top, right, and moving on to the next key. And what that means is now key is no longer kj. Key is going to be me. And then we do the same thing. So we say what is, in our A dictionary, what is the value associated with the key me? That is 1. And so we're taking 1 and assigning it to the same key in our result dictionary. Right? So that means me 1. So notice that the effect of this very first for loop is we're copying all key value pairs from A to result. That's how you would think about at a high level what is the implication of these two lines of code. Okay, well, there is no additional key for us to process after this, right? There's nothing here. So this is done, and we're ready to move on to the next for loop, right? And so in this for loop, now we're looking at lines 15 and 14 and 15. And on these two lines, we're saying using the same variable name for key in, but now we're going to be iterating over B's keys. And so here, I'm going to keep track of this. B is going to be our first, so B is ID 3, the dictionary, and our first key is ME. So key was previously ME, but for good measure, I'll just show that it would have been reassigned to ME because it is the first key here. And now I do the same thing, but this time around we're looking up in B. So B is ID 3. ID 3, the key ME is associated with the value 2. And we're once again assigning to our result variable. So result is the dictionary with ID 4, the same key, ME, right? So this key is ME, the string. And so in this case, we reach something a little bit different, and I want to emphasize this. So here, notice that we already have in this dictionary the key ME associated with the value 1. So what happens when we try and assign a new value to it? Well, it's okay. This is dictionaries are mutable. So what we're going to wind up doing is overriding this. So we just looked up, and this is going to be not 1, but 2, because that's the value that we're copying in here, right? So I'm replacing in this dictionary the value associated with key ME with the value 2. Cool. And that brings us to a good point to move on to the next key. So let me get out of the way here. So now we finished that repeat block. We go back up to the top, and now we move on to the next key. So now our key is EW. This is the next key that we're processing in this second dictionary, B, EW. And we go into the repeat block, and in the repeat block, we're saying, okay, for BEW, what is that value? That's the value 1, right? That's this value here. And we're once again assigning to result of EW this key. So let's go ahead and add another key here. The key is EW, and the value associated with this is 1. All right. We're done with that repeat block. So we go back up to the top and we say, okay, we test, are there any more keys for us? And no, we've finished the process. We finished iterating through all of the keys in this particular dictionary. All right. So we've finished the for in loop there. And now what we're doing is we're returning result. Okay, so let's complete this function out. So what is result? Result is currently the value ID4. And so result is being returned to, let's add this to our table or our diagram. So return value is ID4. We're returning that to line 5, right? So we're taking ID4 and we're returning it line 5. This was here. And so this is going to be evaluated as merged, will be assigned ID4. Right? So we finish this line out and ID4 is assigned to merged. And then on line 6, we see that we are printing this merged variable. Well, what happens when you print a dictionary? Well, we print the literal of it. So our output is going to be a dictionary literal, and that will have string kj associated with value 0. It will have the string me associated with the value 2, and it will have the string ew associated with the value 1. Right? So we've printed merged. We reached the end of this main function. Let me scroll up just a little bit here. And now what we're going to do is return none from main. Again, this is implicit in a function that returns none. And I wrote gnome, not none. And then our program's complete. There's nothing for us to do after line 20 when we return to line 20. So there are a few concepts I just want to emphasize that are new in this particular code listing. The first is, how do we represent a dictionary? Well, we are saying, game 0 was ID 2 here. And notice that this dictionary, we put the type of the dictionary in the header, just like with a list. And then our left column are our keys and our right column are our values. We can assign 2 key value pairs using lines like this one and this one, or notice on the left-hand side, we're just using subscription notation to a dictionary. So result is a dictionary. We're subscribing on that key. and saying, okay, or using subscription on that key, and then assigning whatever this expression evaluates to that key. We saw that we can update key value pairs, just like we did here. So we're updating this key value pair. And then we also looked at how would we, and we're not going to do this too often because this does require keeping track of some things, either with a dot on your paper or maybe checks on your paper or in your head. For in loops, because they are very concise, they hide some of what's going on, some of the state in memory, and that's hard to keep that explicit. But we did keep track of our updating keys as each of these two for loops was being processed. So that's an introduction to working with dictionaries. And one of the other key concepts that's a big picture dictionary concept that I did want to mention is notice that the second time we assigned to a key, we overrode it. And this has to do with our understanding of our keys being a set, right? And so when any subsequent time you assign to the same key, you're overwriting its previous value. You're not going to have two entries into your keys column with the same value, right? So even though we assigned a ME twice, we replaced it the second time. We didn't add a new entry for ME to our table. And this is important. This is one of the common mistakes that I've seen made in working with memory diagrams and dictionaries specifically. Great work on this.